But that doesn't mean nothing changed. There's evidence that the seeds of our humanity were growing in these ape-like creatures. One key difference between humans and apes is the length of childhood. But what do we know about the childhood of our early ancestors?
We knew all about the adult individuals, but we didn't know much about the children.
The brains of baby chimps have an early growth spurt. They're almost fully formed by age 3. In humans, that growth spurt is slower, and it takes nearly 2 decades for our brains to fully mature. But what about Salam's brain 3.3 million years ago?
That, of course, most exciting.
Her skull tells us all we need to know. We have her milk teeth and her adult teeth, which give us her age, 3 years old. And we have a cast of the inside of her skull, which tells us about her brain.
When you have this, you can directly measure how much of the brain was formed at age 3.
From other fossils, we know how large Salam's brain would have been as an adult. So Zerai could calculate how much of her brain was already formed by age 3 when she died. He knows what the answer would be for a chimp.
By age 3, a chimpanzee would have over 90% of the brain formed.
But Salam's brain was only around 75% of its adult size, suggesting it was growing up slower. Childhood would have been her time to learn the survival strategies her family group needed to live in a dangerous world. Perhaps this set the stage for our longer human childhood when culture is handed down. But is there any other evidence Salam's brain was becoming more human and less ape? To find out, compare a human brain to a chimp's.
This is the brain of our closest relative, the chimpanzee brain. Slightly larger than you would expect of a typical primate for their body size, not greatly so.
Scientists look for clues to the evolution of the brain in the folds and furrows on its surface. One important structure is called the lunate sulcus.
In chimpanzees, as in many primates, there's this big, deep sulcus here, the lunate sulcus.
The lunate sulcus is a deep furrow in a primate's brain. It divides parts of the brain related to vision from the rest of the neocortex, which is where more complex thought happens. The human brain doesn't have this deep furrow, and the neocortex is bigger than the vision structures, which have moved far to the back. So did Salam have the deep furrow and small neocortex of a chimp, or had something changed? Brains don't fossilize, but her remarkably complete skull provides a way to see some of the different structures of her brain. A cast of the brain case, called an endocast, preserves the impression of the brain's surface. Ralph Holloway has a collection of 300 brain endocasts from many of our ancestors.
What a paleoneurologist like myself will be looking for are those indications on the endocast that might suggest reorganization taking place. And that's why things like the so-called infamous lunate sulcus becomes important.
Ralph claims that as chimp-like ancestors evolved into creatures like Salam and Lucy, the lunate sulcus, the furrow marking the vision structures, moved back, making room for a larger neocortex, the thinking part of the brain.